All right, guys, we're gonna start up super soon. I feel like you guys are so far back. Come closer if you want. I don't know, these tables, I guess, are those guys's, but they won't mind. Cool. So we're gonna get started up here. Calgary, when you guys are with me, just let me know. Like the cat. Hey, Calgary. Can you hear me? Thanks, Lath. Just let me know, is it sounding loud enough for you guys and clear? I can also do some adjustments if it's not super clear at this point. But if it's sounding good, we'll get on here. Cool. So today is intro to web servers. Should be web servers in there. And have I not had a lecture with you guys yet? I feel like you guys have been here. We've been hanging out, starting to become friends, but I haven't lectured with you yet. For those of you guys in Calgary and those of you here who we haven't connected yet, my name's Travis. I'm one of the full-time instructors here in Vancouver. I don't know, I don't want to talk too much about myself because we've got such an interesting topic. Web servers, it's getting exciting in the program because we're finally getting into the web of web development. Last week you had some exposure to like TCP and sending stuff over the web. This week we're really going to start to see with the applications that you're building, how we can build a full web application. We're getting all of the tools at this point. Before we jump into something new, I thought we could just start with a review on like HTTP requests. So we know that an HTTP request, it's kind of like there are two parties. There's this server sitting somewhere waiting for a request, kind of like someone knocking on their door. The client can come at any time, knock on the door, and usually they're asking for something. With an HTTP request, we're talking about resource-based requests. So when someone is knocking on this server's door, they're looking purposely to have an action done or to get a specific resource or thing. The server is going to sit at home, kind of waiting for someone to knock on their door. The client shows up. They might ask something like, may I please have a cup of sugar? And then the server is going to kind of, on his end, go back and look to see if he can satisfy this request. Server might go to their kitchen to grab that cup of sugar, and either they're going to come back saying that like, oh, I found it, here's the thing you asked for, or maybe they might come back and say either I couldn't find that thing or that request is just something I can't do. At that point, the client has the thing they requested for, and we've completed this two-way transaction of the client asking something from the server and the server coming back and giving their response. This is the request response cycle of any HTTP request. So hopefully at that point, it's something of a review. What are some other things that make up an HTTP request from what you guys remember? Get, post, nice. So get and post are methods of an HTTP request. There are a few other common ones. There's actually like quite a few HTTP methods in total, but the important ones that we've looked over would be get, post, put, delete. These ones help us to do what's known as the CRUD of web development, the create, read, update, and destroy. So when we're talking about an HTTP server, like going and getting this object, in our case, we talked about sugar. They're either creating a sugar, reading the state of like this thing that exists on the server side, updating it, or deleting it. So there's all these different things that we can do on resources, and the method is how we tell what we're trying to do. What else? There's a couple other things I'm sure you guys remember from HTTP requests, like what is included in a request and what is included in a response. User agent, yeah. And what is the like user agent information? Yeah, so the user agent is telling who is making the request, the browser, the operating system. And that user agent information is sent in what's called a header. So in our request, the client might send, they have the method, they also have the path. So we could do a get request to /sugar. And then our headers might say, hey, it's me, I'm like this computer from this browser. So there's a lot of information that we can send in a request and in a response. But one thing to remember is that HTTP requests are a stateless protocol. What that means is that the entirety of the exchange from request to response should be contained in that request and response. Meaning there's no ongoing communication outside of that kind of loop, and there's no like long-term memory. That's why I put like goldfish here and have like a 5-second memory or something. The request and response cycle happens, and it shouldn't depend on any external things beyond what is given in that request, beyond the method, beyond the path, beyond the headers. The server should know exactly what to do. It shouldn't need to know like, oh, what have we done in the past? Have you come here before to ask for sugar? What type of client are you? If it's not in the request itself, then it shouldn't be needed in this response request cycle. We mentioned this briefly, but like HTTP requests are based on resources. They're a resource-based protocol. So often when you make an HTTP request, you're requesting to get something or get a resource and do all those modifications on it. That doesn't mean that there are HTTP requests that aren't for a particular resource. It just means when this whole concept of HTTP requests were created, that was the underlying purpose behind it. Actually, like early on in the web, with HTTP requests, and you guys have heard of like RESTful API, the whole idea was we had a whole bunch of networked computers together, and I knew that like my friend over here had files on his computer that I wanted access to, and he would just allow me to RESTfully request those files on his computer. He would like say, hey, I've got this like document. If you make a request to my IP at this path, you can get this like resource, this like file that I have on my computer. If I trust you enough, I'll let you like do things to that file. So you just had files over a bunch of computers, and people could like request to do things. So that idea slowly got abstracted to the point where we have modern websites and modern web applications, and the form of a resource changed over time from like a document to maybe like a thing in the database or other modern web data that we have. So all that being said, now we can start thinking about web servers. Web servers are the guy that sits there at home waiting for the knock on the door. They handle these HTTP requests and responses. But a web server is both a program that is configured to take in HTTP requests, and also the hardware and computer hardware/computer that runs that program itself and has other resources local to the computer. Those resources could be files like we were talking about. They could be a database with data on it. They could be images. There's a lot of different things. And the server or the physical machine together with that program make up the web server, because the program says, okay, you're asking for this, I can do this thing, but the system itself has the files and information that are going to be delivered back to the client. You'll often hear one part of this referred to as a server in itself. So when you write your first web servers throughout this week, you'll call that program a server. You'll also hear more hardware-oriented people, look at those big stacks of servers. Whoa. These things that you'll see. There's one here. Well, you probably won't see it here because it's behind a locked door. But you'll see all these like server blades. These are like just essentially computer machines that run server programs, but they'll call this physical machine, like, oh, that's a server. And they're both right, but generally when we're talking about servers, it's the combination of both the physical thing that the program's running on and the program itself. Today, we're mostly going to spend our time building our first kind of web servers and see what we can get running. But before we jump into actual code, any questions just on kind of the idea of web servers, or even stuff on HTTP, even though, because that was last week. Maybe who remembers HTTP all the way from last week? Feeling pretty good? Cool. Calgary, I know there's a bit of a delay on the stream, so I'll wait a little longer if you guys have any questions. But while I'm waiting, we have, let's see. Is that good size, bigger? It's good? Cool. So I am in a directory called code. There are currently just a single folder inside of it called public. All public has is some images that we'll use later. But we want to use or create our web server in this folder. So I'm going to create a file. I'm going to call it server.js. Now we have one file and one folder. And then I'm going to do npm init. So we can initialize this project as a node project. I'm just going to hit enter through all of the default cases because we don't really care too much at this point about our setup. The one thing to note, we'll see that one of the options I entered through said, should the entry file be server.js? Because it saw there's only one JavaScript script in our folder, and it says, okay, when you run npm start, by default, we're going to run that file. And that's exactly what we want, so we can just hit enter. And looking over in our directory, we have server, which has nothing in it, and we have package.json. Again, with this one script, so now if we go npm start, it's running node and then server. Not really saving us a ton of writing because I don't know, node server versus npm start is similar in character length, but that's how we set up our node start script. And if we wanted to, like maybe we change the file later, we could just change how we're starting it up in here. Sorry? Main server. This is more information on like what is the main file of the project. If I were to change this to index, if I do npm start, it would still just run this. It doesn't care about this one. But like it might be nice to have them synced up just for communication-wise, or so that our package file is clear. Before we go too much further, I don't know if anyone has used this tool with you guys yet. Where are we? Codecast. We're going to be using coding on a couple different files. Codecast is a nice resource because what I can do is I can say, let's look at this folder, code. No, this is a different one. So I'm going into the lectures folder. Code is in week 3, and we're in day 1. This file here. I'm going to make this public, and I'm going to hit go live, and I'm going to share this link with you guys in Slack. And that way, as I'm coding over here in my editor, you guys can watch and follow along. But with that link, you can see a live representation of the entire folder of this project. Because sometimes it's hard to follow. If I do a bit of coding on one page and switch to another, and you're kind of like, hey, wait, I want to see back on that other file. I forgot what that one line of code was. You can kind of easily check in on it here. So Calgary, here you guys go if you want to follow along with that. It's not like necessary, but some people find it helpful. And Vancouver, there you guys go as well. Just let me, if someone's jumping on there, let me know if it's working correctly. That's good? Sweet. So you shouldn't see anything in there just yet because we haven't really started coding. But as we start going, you can follow along. So we have this blank file, server. It's in our, we started it as a node project. The first thing I'm going to do is I'm going to require a module called HTTP. and this will help us set up our basic implementation of a web server. From here, I can go port, and I'm just going to specify a constant variable for what port I want our server to run on. We're going to say 8080. Just as a review, the port, when we're talking about web applications, we have kind of two parts that map incoming network traffic to a particular program running on our machine. We have the IP address, which uniquely identifies like our computer. But within a single machine or computer, there can be multiple programs running on it, and there could be multiple programs exposing themselves to the network. So that's why we need this port. The port is saying, okay, well, you found this computer. Which program do you want to access? So by saying 8080, when someone goes to my string of IP /8080, it will connect to this program instead of maybe another web server that I have running on my computer. Next, I'm going to go server, and we can use the HTTP module to create a server. This create server function from the HTTP module takes a callback. So I'm going to go function, and this callback wants two parameters. It wants a request parameter and a response parameter. Make it just a little bit smaller. This request, when a request is made to the server, will be the object, JavaScript object representation of that request. The response object that is given to us in this callback will be an object that allows us to create and send a response back to a client. We have the server created, but lastly, we're going to need to go server.listen, and we need to give it a port, and optionally another callback function. We don't need any parameters for this one. This callback will be run once our server is listening on the port that we specified. So I'm just going to do a console log. Server listening on port, and then we'll do port. Okay. So jumping over to my console, I'm going to go npm start. And we have server listening on port 8080. If I go to my browser and I go localhost 8080, oh boy. Watch that one, but localhost 8080, hit enter. Nothing's happening, but I do see that there's this like nice network wheel that tells me it's waiting for something. And what it's waiting for is the response from our server. We have a server. It is listening on port 8080, but we're not sending anything back. By default, our server right now is running, but we haven't specified, like when something comes in, do this thing. What I could do is I could console log the request. This is a really big object, so I don't know how much of it we'll see. And we could, well, if I hit refresh now, I'm not going to see a console log here. And this is the first thing to think of when we're making a server. Once I start this program, it's running continually. If I make changes to the file, like I could delete everything here and save it. I mean, our server isn't doing anything at the moment anyways, but it's still running, regardless of what I do to the directory. In order for these changes to update, in order for us to see a console log of this request, let's make it request. I have to come to the terminal. I have to shut down the server or stop the program. I'm just using Control-C, and do npm start and get it going again. Now, if we try and hit 8080 again, we're not sending a response, But in the server, we get this console log of that request object. So again, it's huge. We can see some stuff that maybe jump out to us, like headers. It's being cut off at the top because we don't have enough space. Something about socket, client. Oh, here's a couple of useful things. We see that there's a URL and a method. So from our browser, we're doing a get. The path that we went through, I didn't specify anything here. I just said slash. So our path right now, or our URL, is a slash. And a bunch of other things. You don't need to know what this whole object looks like. You can look in the HTTP documentation to see some useful methods that the request object has. But the basic things that you're probably going to be concerned with are the URL, and that was the request.url. And we also want to think about the method, which was request.method. But we also want to solve that problem that we're not giving anything back to our server. So we can use the response object to do a response.send. Just send, and we can just send a string back. So we can go now if I save this, head back over to my server, again I have to shut it down, start it up, and we refresh this. Oh, we got one error. Response.send is not a function. Response. Okay. Send. Oh, send should be end. We want to end the response. Start our server again. We'll refresh, and we get this just blank response back from the server. No matter what path I go in here, it's the same thing, although we're getting a different, the same method, but a different path as I type in different things here. So if I go slash users, enter slash dogs, same response, different path that we're getting here and here. The next thing we're going to do is we want to make this server a little more interesting. And I thought the way we could spin this is we can say this is a super secret spy server. Directions to follow. So this is our debriefing server to get missions and answer super secret spy stuff. But it's not fun if I'm just sitting up here doing missions by myself. Not only is that sad and lonely, but not very interactive. So I'm going to use another small piece of tech called ngrok. Ngrok allows me to run a server locally on my machine, but make it accessible to you guys here in Vancouver and also everyone in Calgary. If we just had you guys here in Vancouver, I wouldn't need necessarily ngrok. I could just give you my IP address, and you could go 192. Blah, 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 instead of localhost. So in here, we could go 192. The rest of my IP, and you guys would be able to get my server because we're locally hosted on the same network here in Vancouver, but that would be super not fun for Calgary. So ngrok allows me to tunnel or send my server to kind of everyone. All I have to do is come in here. I have set up ngrok already, so I can just do ngrok HTTP 8080. Saying expose the program on my machine running on port 8080 to the world. If you want to play around with ngrok, it's a little bit out of scope of this lecture, but it's fairly straightforward. The documentation is fairly good. So if you just go to like ngrok.com and follow a couple steps, you should be able to get your, if you have a HTTP server, up and hosted in a couple minutes. But now I have these two public URLs for you guys. There's one, and over in Calgary, here's another. So if you guys want to check that link out, see if you can get our super basic server response. Hello from the other side. Just give me a thumbs up if it's working. Yeah, cool. Hopefully it's working for you guys in Calgary. If it isn't, just let me know. Oh, what about the path? It's by default going to IP localhost. So Lath, yes, by default, when we create a server, it is being hosted on localhost. I don't know if you had a follow-up question behind that. Any program that we run or web server will be on our IP. There's no way that we can change what IP that we're serving a web server on, unless we're using a router to like forward IPs and things like that. Localhost is just an alias or what's another word? I feel like asking what's another word for an alias is very meta. Alias is just like an alternative name for it. So really behind the scenes, localhost is just being converted into what my IP is. When we're visiting other websites, we're still going to an IP address. There's just a layer of abstraction between the IP address and what we're doing. It would be super annoying if every time we wanted to go to like Stack Overflow, we had to like, okay, Stack Overflow's IP was 192.345.675. Like you would just never remember any sites. So with public websites, but you could do that if you know Stack Overflow's IP, it would work. But the layer of abstraction is something called domain names and domain name hosting and domain name servers. And they're a set of servers that when I type in wikipedia.org, my request first goes to a domain name server, and they have essentially just a big like phone book lookup, and they're like, hey, Wikipedia. They find the IP associated with Wikipedia, they send that back to me, and then my request gets sent actually to the IP. So I don't ever have to think about IP, but behind the scenes, it's still very much how my request is being processed. Cool. So any questions at this point? We've got our basic structure. We've got requests and responses being handled, although very generic. Cool. The next thing we will want to do is our server as it is super boring. Any real web server has something called routes. Routes being the combination of methods and paths. And the combination allowing us to do different things with our server. Oh, nice. I see some people. Spy stuff. Sweet. Yeah, we need some cool spy stuff routes. Our first example here, we're using the just like bare bones HTTP module that comes like native with Node. And we're going to see some problems with making a server this way. The first problem that we're going to encounter is that it is kind of hard to do routes. We have one function that handles all of our incoming traffic, and we need to somehow in here say, okay, if the request.url is a get, we want to do some particular set of actions. If the path is this path, we want to do a specific set of actions. There's nothing built in to make this easier. I mean, a super naive approach might be to go if request.url equals get, then do something. If something else, and we just have a big, nice, long case of if statements. The pattern I'm going to use today, that pattern would work. It wouldn't be the prettiest thing, but that would be fine. We're going to use something called a lookup. And a lookup is just an object. It's an object that has a kind of group of functions that we will eventually want to use. So our object will have a key called get, and then associated with the key get will be a sub-object with some paths. So we might want to get /mission, and that'll be something. We might want to get like answer, and that would be something. And what they're going to be are functions that handle the request and response. We have more than just get methods we could do. We could handle a post method. For this one, we're going to keep it simple and just go get, but we'll see some posts later on. I'm also just going to add a default handler, and that will just be a function that does a request, response. And within each of these routes, essentially, we want to do some handling of the request that's coming in. Our basic one could be, just copy this line. Our default is to just send back a response about what our server is doing. Mission, we might want to send mission information. For our default, I'm going to say, this is a super secret spy server, directions to follow. Make a get request to /mission. You don't need the capital mission. In mission, I'm going to give our first mission. What is it's a boring math mission to start with, okay, but we'll build on it. So what is this? And I'm going to do a little bit of a trick here, where for our next missions, we're going to have you guys post information to the server so that you can specifically send the information as if you had put it into a form and send it that way. For now, I'm just going to have a route where if you go to the route which is the answer to this question, you'll be doing the right thing, or you'll get a success on your mission. So this is saying the route to JavaScript will compute the answer, some number. So if you go / the correct number, then we'll get a response dot end. Congratulations, you finished the mission. Let's go here. I think I have syntax thing somewhere. We'll see. So I'm going to shut down the server, start it back up. Nope. Can anyone see what my error is? This? Well, we want the / because our path is going to have to start with a /. with it. Mm. So the comment here in Vancouver is the string notation doesn't work as a key when we're using template literals, and that's exactly what's happening. One solution would be to take this string, save it to a variable, and use it on the left-hand side. The other thing that we can do is we can surround this in square brackets. The same way, well, I guess similar to, we have an object, object1, and we can do dot like key to get a key from it. We can also do square brackets key. Kind of harkens to that. So we have a dynamic, somewhat dynamic route here. Oh, actually, before I make it live, so you guys can try it, I'm going to go const say equals require. So say is just a node module that lets my terminal or my console like speak. So when someone does complete the mission, I'm going to go say.speak. I think, of course, because it's a node module, I will first need to go npm install say. Let's start this up. Now let's see, I'll turn my volume up, if anyone's solving the mission. So again, going to / we get, there's secret spy server directions to follow. Oh, no one is going to be able to solve anything, of course, because I set up the routes in a lookup, but we're not actually handling them yet. So false alarm, my bad. We have the URL and the method, however. And so what we can do is we can say from the routes, grab the request.method to get our first layer in our lookup. So find this object if they're doing a get method. From that, find the request.url. So find the path. And then run the function associated with it. I'm using parentheses and pass in our request object and our response. Our response object. This should work. I'm going to do an extra check just to handle our default routes so that if someone doesn't provide a valid method or URL, our server will still work. So I'm going to say if request.method is in our request. So it's checking request.method, which will be get, post, put. Is that key a valid key in our request lookup? Is it either get or default? If it is, then we want to do all of this stuff. We want our condition to be a little safer, though, because that'll only assure that they're using a correct method. We also want to assure that they're using a correct path. So I can do a second check with ands, and I can say, is request.url in request of that method? So we're saying now, okay, we know that, say, for instance, get is in request. Is /mission in request of get? So in here, do we have a corresponding path? If both of those are true, then we do have a route that'll handle this, so we can respond with the route. Otherwise, we can just go routes request.method or requests, sorry, routes of default. And we'll run the default method. Now I think we're good to go. Control C, PM start. So we're listening. Let's look. If I go to localhost, it tells me to make a GET request to /mission. If I go to /mission, make a GET request to /mission. Mission. Request is in request, and request.url is in, oh, yeah. We'll do a test if our second here. This is a good chance to use the code cast thing. You can check it out yourselves. I'm going to go to /mission, and we'll see. I'm getting undefined for this. So our check to see if request.method is not working. So we're getting undefined when our method is get. Routes request.method. Oh yeah, you're totally right. And request, are we doing? Yeah, so that was the problem. We have routes here, routes here. Get rid of those console logs, and we'll try one last time. So our base one was working.
Congratulations. Congratulations.
You guys are quick.
Congratulations.
All right, we're getting people getting there. Sweet. So that's like, I think it's kind of like a nice representation because you hit enter and my server over here is kind of responding back to you guys. Nice. So not a lot of slick spies out here. But as you can see, I mean, even in the end, I got a little tied up in using the lookup. I'm going to turn it down a little bit. This maybe isn't the easiest way to create a bunch of routes. For one, we're dealing with like nested resource or nested objects here. I've got one layer for my methods, another layer for paths. If I had bigger routes, we had like posts in here, this could look really big. It's a little bit clean here because we're looking at or using a lookup, but not the friendliest way to do it. So that's the first kind of problem with making a basic server using HTTP. Any questions at this point on this kind of layout of our server? On either what it's doing or how we could get it to do more things? Is the code making sense? I can kind of scroll through it here, but if you want to open up that codecast link too, you can probably scrub through it a little better. Yeah. This part here? Yeah, so the question is, can I explain this if here? So we might be using some syntax that's kind of new, particularly this in keyword. So the pattern is I have a string. Request.method is a string. In our case, this could be, this could be something like get or post. And we're checking if this string is in the second part of this syntax is an object. And that's when we can use this in keyword. So are these keys essentially in this object? So we're checking is get, post, or whatever methods are being passed to our server inside our routes object. And so routes has two keys, get and default. And when I say routes has two keys, the routes object, we're thinking about the first layer. Because if I go routes dot get or routes dot default, both of those will work. But if I try and do routes slash mission, although this key exists somewhere in this object, it's not like a top level key, so I can't access this function from routes. The same way here, when we're going something in routes, it's looking for those top level keys. So our if statement is checking, well, does the object have the correct method inside of it? Does it have a key that belongs to whatever method our client is asking for? If it does, we pass our first check. But that's not the only check we need to make. We also want to check if the request.url, which again is a string, the string could be slash mission, which is a valid one, or it could be something like slash thing, which doesn't exist. And we're saying, does this key, or whatever key is passed in, exist in this sub-object? This is a sub-object because we're getting routes of request.method, which will be routes and one of its sub-objects, like this sub-object here. So we're saying, does a path slash mission or slash thing exist in like these keys here, mission or slash, and so on. And we're able to grab one of these kind of sub-keys, or sorry, sub-objects, because our first check passed. So we know get is a valid object, so therefore we can check if a URL is in that object. If the thing we pass is not a valid object, then we don't go to our second check. If you have a series of and checks, you check the first. If it's true, then you check the second. If it's true, then you check the third. But if the first is false, you just stop there and you don't have to check any further. So we know this is real because the first one passed. I could have done this check in other ways as well. Like I could have just said if routes of request.method and routes of request.method request.url. I could have done something like this. Because this will return something truthy if it exists. Otherwise, it's going to return undefined. If I do routes square brackets of just something like that, that isn't a real key, this will return undefined, which is falsy. Otherwise, it's going to return something which will be truthy. So falsy or truthy, and then secondly, falsy or truthy. Same thing, but we're checking for stuff in this smaller object. So a little complex. And again, that's one of the reasons why setting up a server in this way, just using the basic HTTP implementation, is not the easiest thing. So if this kind of syntax frightens you a little bit, that's OK. I don't think you'll have to be using it in this way. We're kind of demoing it as maybe like a cautionary tale. If there's no more questions, we'll break for 10 minutes, come back at 11:03. I always like to encourage people during that time, like during the break, if any questions come to your head, Calgary, if any questions come to you guys over there, think of them and bring them up when we come back, and we'll start with questions when we start back up. Yeah, come back at 11:04-ish. Yo, man. I'm glad to hear you solve your problem.
Yo, I was so scared. I was like, yo, I can't set up my project fuck. I was like, I started on Friday, started on Saturday, I did everything else. It was like, I can't tell, and I'm like, it's like, it won't let me, and then.
If they're not super techy, are they really going to pass? I wanted to have a shower.
The coffee machine drink.
It's a half hot chocolate, half Colombian.
Like you actually do half, and then you don't just get the mocha.
Two smalls, and it gets like right there.
Nice.
I saw someone press the button and was like, use what? It was like, off the lottery. Roulette. I don't know where you like.
I need to try that. Probably the gourmet drink.
That's pretty funny. I remember they had like a hidden away that was like 75 cents for pop, but it was like, again, like a roulette, like it was just a random. Yeah.
3 letters.
Yeah.
Good, alright.
Good.
How was the weekend?
Good. Yeah. Nothing too crazy. What about you?
I was here this weekend. Got my storage freed up.
Oh, nice.
Got 3.
Yeah, I saw you guys hacking away at it. Is it good now?
No. It's so we got it down to 4.7. Deleted wirings, reinstalled it, destroyed everything.
Yeah. Initialize it?
Yeah. And now I've been adding some of these projects. I chopped up about a gig, so I have about 3.5. So we'll see how the week goes. I'll probably have to just chop it again at the end of the week. So.
Okay. So goes the process.
Yeah. How was the weekend though? Did you do anything cool?
Nah.
Oh, it's gorgeous.
What did I do? Yeah, nothing really. I went climbing one day at the gym, and then kind of just hung out. We got a Switch recently, so we've been playing a lot of the new Zelda game.
The Breath of the Wild?
Yeah, Breath of the Wild.
Is
Yeah.
that new or is it just new to you?
New to me. Like I guess came out last year.
Yeah, I heard it's really good.
Yeah, it's really cool.
The console for.
Yeah, we almost did it that, but
Were you a
there's
Zelda
other
fan
ones.
before?
Yeah.
Me too. What was your favorite? What's that?
Of all of them,
Or name some of your sort of most played favorite story.
I think this is controversial, but I really like Wind Waker. Wind Waker was one of my favorites. Yeah, I like Wind Waker a lot.
My favorite, I think, was. I mean, you can always say our friend, but I think my favorite was Majora's Mask.
Yeah, Majora's Mask is really fun too.
It
Yeah.
was very intimate.
Yeah.
You got to know the stories.
And it's just like a dense game. Like the town, because of the whole time aspect, there's just so much that happens in that one small space. It's really cool. Yeah.
And like I said, it's also like intimate. Like you know the stories. You see like
Yeah.
balls with everybody, and you're like, oh no, you're doing that again. So,
Yeah. No, that's a really cool part of it. Yeah, they're good games.
when I first so I asked for that for my birthday. I think it came out around like October, November. So I got it, and I remember we were playing it the day of my birthday, and it was the time crunch, and I absolutely hated it. But as you started playing, I was like, oh yeah.
Yeah. Remember, as a when you're young, things like that get like. I remember playing. Yeah, I remember playing this like. I don't even know. I have no idea what game it was, but it was like you had these like monster pets or something, and like they could like get hurt or like if they didn't get fed. And as a kid, like I liked playing it, but I just got so much anxiety. I was like, oh no, like my pets, like I would just like freak out.
Neopets.
Yeah, that type of. Yeah,
Yeah. Putting time pressure on like
Yeah,
anybody is.
yeah.
The Breath of the Wild is like traditional. Like it's like open map.
It's so there, like the puzzles, the style of combat feels the same, but it's just like very open world, more so than any other Zelda game, and it's not linear. Like it's kind of not linear. Like you can do any of the dungeons in any order. There's an easy way to do it, and it's I don't know. It's pretty cool so far. About it is it has super emergent gameplay. So like there'll be a problem and you can solve it in a bunch of different ways because of their physics and the different tools you have. And there's like a lot of systems they put in. So like if you light the ground on fire, it creates an updraft from the heat. So you can jump over the fire and use your like parachute, like your glider, and fly. There's like a bunch of things like that that are just like you can add them together in cool ways and get like super interesting results.
It's like life.
Yeah, life.
Yeah, no, that's really cool. I hear that's an emerging thing in game design where it's the emergent.
Yeah.
What's it called?
Emergent gameplay.
Immersion?
Emergent.
Emergent.
Emergent because it's like you build the building blocks and then you just let them go. And there's like if you have 10 things that can be combined, you know, with each other, then you get hundreds of different
Permutations.
exactly. Players get to do things that like kind of the developers didn't fully plan for.
Edge case.
Yeah.
Like I can't. Like what kind of tests?
You kind of just let them go.
Yeah.
Like people, for instance, there's a lot of this like hacked them really fast or like really easily because they're just really creative in how they use the different things. But I think the creators are kind of just like, yeah, like that's cool then. Like if you didn't have to do the full puzzle because you like launched yourself over a wall, like if you can do that with our system, fine.
That's a really big leap in.
Yeah.
For game developers, like, yeah, I think it's really cool.
Yeah, I think it's cool.
Like that. But it kind of takes away from some of the, you know what, I guess writers of the story are probably like, no.
Yeah, without the, yeah.
I was also actually. Really, I like it. I like it. Starting to.
A little bit, yeah.
Yeah. I got bought some toys on Friday. It was so good. I bought, you know, Sing Seiya, right?
Yeah.
Yeah, I got this shit. And then
The whole concept?
no, this one, it's just like.
Okay, we're gonna get started again now. So any questions or thoughts come up during the break that we can look at to start with? How about you guys over there in Calgary? Any thoughts or questions on the code so far? Thanks, Sam. Sorry for not muting you guys. Yeah, you get it. The pause screen on here in that room like mutes it automatically. Here you have to like hit the button to mute it. So sometimes I forget to like mute it, and then everyone just hears my personal conversations during the break. And I probably say like embarrassing things. So cool. If any questions come up, just throw them in Slack. But we'll, yeah. Do you want me to come? So the question was about a assignment for today using curl.
We didn't use that here, did we?
Yeah. So curl. Have you guys haven't used curl at this point? Or you have or you haven't? You have. Oh, so was your question just on curl in general or specifically the flag? Yeah, so curl allows us to make HTTP requests from the command line. We did our request just based in the browser, but we could have done curl to, for you guys, not localhost, but this path that I shared. So you could have done curl to HTTPS 003 this, and done a GET request and gotten the response from the server, which in our case would have just been like a line of text. So you could have done this application from the command line just the same as we did in a browser. Browser's a little bit easier when you're testing just plain GET requests because because you know it's we just put the path in here and it sends the request and it works. Curl is a little useful if we want to do testing for other HTTP methods. In the browser, I can't readily do a post request or a put request or a delete request. With curl, you can specify the method, the path, and like do tests on a server. We'll look at that a little bit later in the lecture on how we can test these other methods. For get, it's kind of so easy to do a test in the browser that I end up using browser a lot. The other tool that you can use with the browser is if you open up your handy dandy inspect or dev tools, the network tab has a lot of information on, so if I refresh this, we can see the different HTTP requests that happened for this site. So the first one here says mission, and that's because we did a / mission. If I click on it, I can see the request itself with the headers and all the information that was passed. I can see the response. In this case, it was, just what is this big string of numbers. So that's another thing you can peek into if you want to look at the network tab. Network tab also, you can select slices of time, so you can see for this area what request happened. So playing with both of those is nice. So we left off and we had just created our basic implementation of a server. We saw some problems. What were some of the problems that kind of came up with our server? This implementation. It's complex. It was kind of hard to handle routes. That was a big one. Another problem with this one is if we want to do post information, when you send a HTTP request with post, you have the option of sending extra body data. So the way that we see this in most cases is with forms. If there's a login form or a sign up form, you fill in your email, password, and you hit send. That information from this form is sent in the body of the request. In most cases, it's not sent in like plain text though. It's sent as an object encoded a certain way, and that's a little bit hard to handle with this basic implementation. There's other reasons why just a basic HTTP server can be challenging. And so the solution to that is something called Express. Express is a routing and middleware web framework, but practically that just means that Express helps us make a web server where routing and managing incoming HTTP requests is much easier than an HTTP server. It says like Express has minimal functionality on its own, but it uses a series of middleware function calls. So middleware is probably a new term to us. What does middleware mean? We'll look at that in a second. Express helps with routing and middleware, but middleware itself is just a function or a series of functions depending on how it's used. It's anything that needs to happen between the request and the response. So a route in itself, the way that we have defined here is kind of functioning like middleware. But middleware doesn't have to be a route. It doesn't have to like end the request response cycle. It can do like pre-processing. It can do a lot of things in your response request cycle. Things like, I don't know if we have, oh yeah, we do. Authentication, logging, cookies. I don't think, we're not going to look at cookies today, but it's something you'll cover later this week. But we can think of a case where our application, maybe our super secret spy application, we only want like registered spies to be able to get missions. So we throw some middleware in that is a function that every request that comes in, it runs and checks, is this person like a spy? If they are, let them see the next route. If they're not, just like stop the request here. We also have middleware for stuff like formatting the data that's coming in. If the request data is coming in a specific way, we want to format it. If we want to log every like error logging or just use case logging, when a new request comes in, maybe we save it to a file that says, this time, this request was made. We have a nice log of all of the history for our server. Middleware as functions, they have access to the request object, the response object. So the same way our routes we pass them the request and the response object. Middleware functions within Express will have both of those objects. And they also have another function passed in as parameter called next. Next allows one middleware function to pass on the execution to the next middleware function, like the next thing I kind of like to think of it in like the assembly line. So the request comes in and it gets processed, by each of these middleware functions continually until it either ends the request response cycle or hits a route, something like that. Express itself is very minimal. It doesn't do a lot of stuff by itself, but it's in how we add different layers of middleware that we can build up a more complex server. So like even in this like GIF, like each of these like robots is doing a very simple task, but together the combination of all of them is a more complex set of tasks. Middleware functions can perform a bunch of things. They can execute code. They can make changes to the request and response objects. They can end the request response cycle, like they can terminate it early if they want. They call the next middleware function often. Yeah, let's get into some practical examples before we go further. So I'm going to save this. This is our old server. I'm going to add a new file. Actually, first I'm going to change this to server old. Make a new file called server.js, and we'll get Express set up. First thing we're going to do is we're going to make a new variable called Express, and we're going to require the Express module, Express. Unlike HTTP, Express is not a included module within Node. So if we go over to our terminal, shut down our server for a brief second, and go npm install Express. While Express is being added, the next thing I'm going to do is going to go const server, and we're going to use Express. We've exported from Express module Express, which is a function, and we can use that function to create an instance of our server the same way we did this. This functionality and this one is very similar. Next, we still need a port. And finally, we can go server.listen. We'll give it the port number. And similarly to our other server, we can give it a function and console log server listening on port. This is the simplest Express server we can make. And if I go npm start, we have server listening on port 8080. We have no route handling at this point, but instead of having to do a complex, trying to move this up actually, instead of having to do a lookup like we did before, Express lets us create routes in a very simple pattern. We can go server, so whatever variable you've initialized your server on, dot, and then an HTTP method. We can go get, post, whatever HTTP method we want. We'll start with the get one. And then you give it a path, slash, as the first parameter, and then a function to handle that request, which will take in the request and the response. And this is where we can do similar things to our request and response handlers here. For this one, we'll just send a message back to the client. So we're going to go response.send, and we'll do the same. This is a super secret spy server. Get your missions at /mission. If we want to create another path, you can just copy the same route structure And this will be slash missions or slash mission singular. And we can do the same, like what is and then finally we'll do a third route. This time instead of a get to answer, I'm going to do you have to answer your missions via a post request to slash answer. And when someone posts an answer to this request, we want to get it in the request.body. And maybe we'll have everyone post that answer as an answer. So we will have an answer in this form once we set it up. So I'm just going to go answer equals. And we can do a test. If answer equals this guy, then we can do a response dot send. Congratulations, you finished your mission. Otherwise, their answer is like wrong, so we can send try again. So now, instead of just having like a static response, I mean, like when someone goes to post slash answer, the same thing won't happen every time. It depends on what they're giving to us. We'll look at getting this working in a second because we haven't looked at how can we test this post request for you guys. But let's just get a general test. Can we go to just slash and can we go to slash mission? Is our server configured just for those two things? Now I could, continue Control-C and starting up the application, but as we saw in the first half of this lecture, that gets kind of tedious. Every time I make a change, having to shut down the server and restart it. Anytime something is like overly tedious, often someone has thought of a tool to kind of help you with that. In this case, a tool that we can use is called NodeMon. So it's a Node module. I can install it for this project. While it's installing, NodeMon is just an alternate way of starting a project. So in the command line, I'll show you the command line version after. But in the command line or in our scripts, so if I open up our package.json, our script is starting Node by going node server.js. Since I'm installing NodeMon, I can start the script by going nodemon server.js. NodeMon will run your code the same way Node does, with the one difference that anytime you make a change to your file, it's going to refresh or restart that program. So I can do here nodemon server.js. So this is me trying to run it locally. I don't have NodeMon installed globally, so it's not running. I have a local version of NodeMon, so I could do like a local path to it, /, but I don't know the local path off of my head. However, when it's run by the script, it's looking for the local version, NodeMon server. So npm start. This script is run. It's just doing nodemon server.js. Our server is listening on port 8080, the same thing is going on. So if I go to /mission, I get the question. But if I want to change it, I'm like, okay, it says what is, that's like pretty bad text to give a mission. I can head over here into server, and I can change this to your mission is : what is that? I save. We get a restart from our server, and without having to do anything there, I can just refresh the page, and I get an update to the response. So when you're working with a continually running script, such as a web server, NodeMon is like super helpful. And the one thing to note, however, is that if you are running your programs in Vagrant, you're going to hit a problem if you try and do it in the same way that I did it. And the reason being, NodeMon is looking to see if any files are accessing, or any programs are accessing this file, server.js. So a text editor, the terminal, if anything's touching this file, it starts to watch it and look for changes. If it senses a change in that file, it restarts the program. When you are running NodeMon in your Vagrant machine, it's essentially another computer inside of your computer. So it's looking in Vagrant, is any program opening up this script? But then you open up the script outside of Vagrant with your editor, and Vagrant doesn't know that you've done that. You make some changes, you save it, Vagrant's kind of blind to those changes, so it's not going to restart the server. What you can do is you can tell NodeMon to use -L, which stands for legacy, and it will check whether server is being changed by using polling. Polling is just like continually poking server to see, like, are you different, just every certain set of interval. And that'll work in Vagrant regardless. So this -L is just the extra step you need to do for Vagrant. Okay. This should still be available to you guys. You should see both of our routes. But the last thing is we want to make it so that you can post your answer to /answer. Now, one way of doing this that we heard just after the break was using something like curl. And that would be fine. The syntax for creating a post with the correct body data in it is kind of long. So a tool that you can use that's a little more friendly than curl is something called Postman. Postman is just an application for testing web server routes. We can give it a method and a path, and we can send the information. So I can go get to localhost 8080/mission, and I can hit send, and I can see where are we? The body of the response. Your mission is, what is this text? I have two kind of delineations here. We have the top tabs, which are for my request, and the bottom ones, which is what is returned. We can see the body, cookies, headers, all of these things for both. So not a ton of extra usefulness over the browser when we're just doing GET requests. The one benefit is I can save different requests here. So maybe this one's saved, and I add another one. And if you want to do a bunch of requests and save them and test your APIs, you can here. But I can also do a post request. And I can do a post request maybe to /answer. And with my post request, I can specify what type of body information I am sending. I have options here: none, form data, this form URL encoded, raw, binary, and so on and so forth. The one that will be most helpful to you guys is this form URL encoded. When you have a traditional HTML form, so like the logins and sign-in forms or the registration forms, they send information in this form, or in this type, form URL encoded. So by creating a couple key value pairs here, I mean, I already have one set up, answer with the value 5. I'm simulating entering the value 5 into a form for answer. And I can send that to our server, and our server will be able to receive, move this, we'll be able to receive that body data. So what we kind of want to do is I'm just going to console log request.body.answer. And I'm going to say a post to answer. And what I'm hoping is that when I do this post to answer with the body of answer and the value 5, that my server will be able to get that answer, do a test on it, and we're also going to log it beforehand. So that's my hypothesis at this point. I want to be able to take in post data so that people can secretly send me their SPY answers, not publicly by the URL, but in some body data. And then we can either tell them that they're correct or reject them. So that's, again, the hope at this point. I can do the send right now. And I get this error back. It says type cannot read property. If we look over at our terminal, which was here, cannot read property answer of undefined. So my thought was, okay, the request has a body. I want to get the answer from it. But I'm not able to extract an answer from the body at this point. The one reason is this difference here between the body of a post can be all of these different types. I just have to specify for my Express server what type of body data I want coming in. And to do that, we're going to use our first piece of middleware. So I'm going to get another module called body parser. And here, before the routes, we're going to create a section for middleware. And to use middleware with your Express application, you do a server.use. And then you specify what middleware you want to be used here. For us, we want to use a function called body parser.set, .url encoded. This function will take in all incoming data in the body. It will parse it to convert it from an encoded URL encoded type to just a JavaScript object, and it will put it in a available object assigned to request.body. So if we save that and run this again, we get another response, try again. But if we look at our server, post to answer, and the value was 5. So we're getting a real answer, a real value from the post itself. We're not limited to using pre-made middleware. We can make our own middleware. You can do any function in here. So we can go server.use, and I can pass it a function. And we saw in the notes that the function is going to take the request, the response, and another function called end or next. And this function here could do any number of things. We could have it authenticate the user. It could log info. It could, body parser, make our data easier to grab. It could do some parsing, a bunch of other things. Maybe we'll just do a console log of incoming request. So if I save this and we do a request to /mission, I now see that it's just hanging, it's waiting. Well, we can investigate in our terminal. I got an incoming request, so my middleware was hit, but nothing's being sent back to the client or me in this browser. The reason is we use this body parser here as first middleware, then we're using this middleware, but it seems like we're not getting to these route handlers. And in order for this middleware to continue on to the next thing, we have to use the next function. So here I'm going to go next. And now if I try that same endpoint, it doesn't hang, it gives us the response. It still logs that there's an incoming request. But the middleware, you know, like the relay baton racing, like the first guy runs and he hands it off to the next guy and then he runs. That's what our middleware is doing. It's running its function. When it's done, it's using next to hand off the request to the either next middleware, or if we're done with all of the middleware checks, it'll hand it off to the routes. Yeah, next itself is a part of Express and just part of how the framework handles middleware. So we have two pieces of middleware, this one doing a bit more than our second one, and then our two routes. I would encourage you guys, if you want to, I'm going to put some more complicated questions up in a second. If you don't have Postman, maybe give it an install. If you have it, you can use not localhost, but the URL that I sent you guys in Slack, and just do a try a post to /answer and give it like either the correct value or incorrect value and see what you get back. As you build out web applications, something like Postman is like really helpful to test out your backend to make sure it's doing all of the correct things. Because one way to test out your web server is to say, okay, I want my web server to do X, Y, and Z, be able to handle all this information, and then the front end should have like forms and pages so that I can do that. I'll build both, and then I'll test both. But then you have, you know, a form where you're entering data and it's not doing what you want. You have such a broad area of code to try and debug. Is it because the back end is not working? Is it because the front end you didn't set up correctly? Is it because you connected the two of them in the wrong way? If you use something like Postman, you can kind of isolate the back end, or you can isolate your problems down to like a single route. If I can't do a post to /answer, it's not my front end that's wrong. It's specifically something in my back end. So it's a good testing tool to see kind of what's going, and lets you test early on before you necessarily have a front end even like created. So let's look at this was our question. I'm going to cheat and just put it in. Oops. So 202, I'll pop into Postman. I'll do a post with 202 under the key answer. Uh-oh. Oh, I know it's wrong. Let's... So what is wrong in doing this? This line, particularly on line 30. Yeah, well, for one, we kind of don't know what the type is when we're getting the answer from our request. And the comment here is it a string? In this case, yeah, it will be a string, and all of the post data will be. So I just need to do a conversion from string into a number. And if we try, where are we? If we try that again, hopefully we get the congratulations, you finished your mission. So already we're seeing a lot more usefulness for our Express server compared to that HTTP server. We have a really fast and kind of sensical way of creating routes. We have middleware that we can use to handle and process our requests in different ways. If you search Express middleware, you'll find a ton of NPM modules that you can use for your projects, things that people have already created to help you do a huge variety of useful things. So this is nice in pulling other people's code to help you do things. You can also obviously create your own middleware. You have post data. The last thing that Express is going to help us do is templating. So currently, all of our clients are just getting a string sent to their browser. Not super user-friendly. What if we want to have like full HTML like templating to show a real page with HTML and CSS? We're kind of limited, at least in the tools or way we've been using Express at this point. Luckily, Express has support for templating engines. And this is just a way of sending both an HTML document with data from our server to our client. If I go server.set view engine EJS, set is another keyword or function we can use on our Express application. We've used server.use for middleware and server.a method for routes. Server.set is more a configuration thing for our Express server. You do it once in the initialization of your server to set particular variables. Here we're saying the view engine for Express, we want you to use EJS. It should break on this because oh, looks okay. Maybe the reason I thought it would break is because we don't have EJS installed. It still might break on us yet. But now that our view engine is set, instead of using response.send, we have another option where we can do response.render. And we give it a particular template to render and the data that should be paired with that template. So in our case, we'll do something called index. And the data that we'll give it for experimental purposes, we'll just make some data and we'll set test to the value hello. And we'll pass that down in our response.render. Or actually better, we can take in this string that we had defined here. Someone makes a request to the index now, it's going to look for a template and try and give it the data. So let me give it a try. Cannot find module EJS. There's where it breaks. So our first step is going to go npm install EJS. I will start the application up again, try our request a second time, and now we get a second error, failed to look up view in the views directory. So I specified I want it to do a render of the index view given this data. I have not created this view, so that's the error I'm getting. It's like, what is index? I have no idea what this is. By default, Express is going to look for views in a folder in the root directory called views. In this folder, I can create any files. So we can go index.ejs. And to start with, I'm just going to do plain HTML. I'm going to go hello. This is the index template. So our server is looking for something called index in the views, and it's going to render it. So refreshing our page, I get still very plain looking page, but it's in HTML. So given time, we can style this up real nice. We got hello, this is the index template. At this point, there's nothing really like new about this compared to just like a static HTML page. The big difference between templates and our rendering engine with Express is I can inject information or I can inject JavaScript into this EJS template. And the way I can inject JavaScript is with these sharp percentage sharp tags. Anything in here, this is JavaScript. I can run any JavaScript I want in here. And I have access to the variables that I passed here, or the data that I passed into the renderer. This is the template. This second parameter is often called template variables or template vars. So in my index, I should go, I have this data. I have something called test, which is a message. So I can say, let's do test dot, or we can just do test. Refreshing, I'm not going to get anything. The JavaScript is still running, but it's running silently, or it's not being outputted to the template itself. If I want the JavaScript to be run and outputted to that point in my template, I just have to do an equal sign on the opening EJS tag. So sharp bracket percent equals, and then the percent sharp to close. Now we're going to get, this is a super secret spy server. You get missions at /missions. Our application at this point is pretty basic, but just being able to do this is kind of powerful, because if our server was more robust, we could maybe be making requests to a database, we could be doing some calculations and getting a bunch of data dynamically and inserting it into our web page. So if I go to /mission, maybe I want to be able to get like more than one mission and pull it dynamically from some information on our server. If I just had plain HTML pages, it's harder for me to do that. Before we look into getting it to work dynamically, any questions on this structure of our Express application? I'm thinking about middleware in particular and our EJS templates. Yeah, super good point. So the data I'm passing down is in an object, and it has the key, test, and the value this thing. So the thing that might make sense is that I would go data.test to get it, because it is in an object. The way EJS works is it takes this object and makes each key a publicly available variable within the template. So test would be a variable available. If I go thing and set it to 1, I do 2 and set it to 2. I will also have these variables available in my template, but just as thing, just as 2. So I can go and not data, but just thing. I crashed the application. Oh, I was adding stuff up here. So I'm going to put back on the say in a second. So this is our first variable. Our second variable was set to 1. We're accessing them just on their names as they appear in the keys of our template vars. So turning it back on. If anyone has Postman and they do a nice post to our answer with the correct answer, we'll get another congratulations coming out. But so far, it's okay, you can say it. Our SPI server is pretty boring. No one wants to go on a SPI server and do math questions. So what I have, actually you can't see it here, and that's because I've shared this folder with you, and I didn't want you to see the answers to my riddle questions. But above this directory, I've got a secret questions folder with some riddles, answers, and a reward if you answer the riddle correctly. So what I'm going to do, I'm going to go const question 1 equals require I have to go up one directory because it's hidden, go into questions, and then I think it's just one.json. So this will be a JSON object. And when you get a mission, I don't want to send the same mission every time. I want to send like a variable mission or a different mission depending on maybe a number that you give me. So I want you to say, get mission number 1, get mission number 2, and be rewarded with like different missions. I could say, okay, well, I'm going to make a path for mission 1. I'm going to make a path for mission 2. And I'm going to make a path for mission 3. And that would work for our purposes because I was lazy and only made 3 missions. But we could think of servers that have to deal maybe like hundreds or thousands of like users or hundreds or thousands of a particular resource. And you're not going to make 100 or 1,000 routes to handle all the different combinations. Or even we can think of cases where our server, we want to dynamically get a resource and we don't know what the number will be after it. You know, this number here could be like anything. It could be, 1, it could be 1,000. We kind of like don't know. So what we need is a route that can handle a pattern. We want the pattern to be missions / some number. And no matter what the person puts, if I go missions / 43 or missions / like a huge number, I want it to hit this route regardless. That's the next like big improvement that Express is going to offer on our HTTP server. The way we can declare a pattern matched route is to do colon and then a variable name here. So now if I go to /mission /34, I get the same response, and it's being handled by this as if I do mission /567. I get the same thing hit. So this route will pattern match any URL that has the pattern mission / something. And not only that, but we can get this variable from the request. If I console log request.params.id, anything with a colon before it within the route creation is called a route param, and you access it by request.params and then whatever it is called. It doesn't have to be ID. This could be dinosaur, and then this would just have to match. You can also have more than one route param if you wanted to. You could do /second. And then any pass that went mission /something would be handled by this route. In our case, we're going to start with just 1. And we're just going to start with logging that param. In our server, I now have that information server side, and I can do whatever I want with it, depending. Nice, 340. In our case, we said that we want to get the param and deliver a different mission depending on the value. So if the param is 1, I want to give a certain mission. If the param is 2, I want to give another mission. And we can just do conditionals on this. I could do a simple if statement. If request.params.id equals 1, then I want to do something. Else if request.id equals 2, I want to do something else. Finally, if it's neither of those, maybe I'll have like a default reaction or mission to give. And I'm going to do res or response dot. We can do maybe a template for this. So render. This will be our missions template. And the data that we want to send with the template will be different depending on the params that are sent in. So I have one mission up here, question 1. So for our first pattern match, we'll do question 1. For our second one, I'll get a question 2. And then for the last one, the default, no matter what you type that isn't the first 2, we'll get a question 3. I also need to import those. So 2, 3. If we had more time, again, this would be something that would be nice to use a lookup for instead of just a big chain of if statements, or maybe even dynamically require that question based on our params. But this is kind of a clear way of doing it, and maybe an easy way to get it working fast. If I'm doing a render for missions, before we can test it, I'm going to need to add a missions template itself. So if we go mission/564, I get your mission is. I also have 2 parameters. I passed in the question.json, and because I made those, but I'm not going to show them to you because they're secret, they have a question, an answer, and a reward. In this case, we just want to put the question down. So our EJS sharp tags, question, and then I'm just going to put some information. Submit your answer to post/answer. So now if I go mission/1, I have 1 riddle. If I do mission/2, uh-oh. I have the same riddle. So our routes are something's fishy, and it's probably the same error we had before where we're comparing a string with a number. We can also just do the double equals to get some type coercion. So now hopefully if I do 1, I get 1 riddle. If I do 2, I get a second one. And if I do 3, I get a third. You'll get Postman spinning up because you want this reward, all right? When we do a post to answer, I'm going to change this because now I want to do if answer is equal to, So we want to accept posts for the questions, right? There's 1, 2, and 3 questions. So the same way our get request pattern matched based on the question ID, we'll do the same for our post, :ID. And we will check if, I'm going to copy this set of if statements there, post it right in. For request.params equals 1, then then I'll say the solution equals question1 dot answer. I'll make that let. So if you post to 1, you'll get question 1 answer, question 2 answer, and question 3 answer. And then lastly, we're going to do a check if answer equals solution. Then we're going to do a res.send. And it will be, congratulations, your reward is at. I'm not going to do a template for this one just for time's sake, but we could add the answer solution to a template. Oh, I guess the reward also has to be dynamic, so it's going to be empty. And then it's going to be the question.reward. Otherwise, we're going to give that same message. Just try again. Okay, we're getting closer. So there, still working. In Postman, if I do a post to /1 and I try and say the answer is 202, I get try again because that's wrong. It's not the riddle question. Lastly, yeah. Other than Postman? So let's look up curl post. So you can use curl if you bring up your terminal. I would follow something similar to this. So you have to specify that your content type is going to be application/x-www-form-URL encoded. And then you specify the values that you're putting in. This is the reason I think it's like a little bit easier to use Postman. It's because this is like not, it's the syntax for doing a GET request with curl is pretty friendly, but for post requests, it's not. And every time you do a new one, you have to change this. It's easy to make mistakes on the terminal. Postman. I think you can. You used to be able to just use the web application for Postman to make posts, but I haven't been able to find that recently. So yeah, if you don't want to use Postman right now, just look up the syntax for posting with curl, and you can do it right from your terminal. I can do one example with each, but first I'm just going to put the say.speak on here so we can see if anyone's getting. So let's see. First mission, maybe we can do as a group. So David's father has 3 sons, Snap, Crackle, and David. Yeah. So we'll head over to Postman. I will try a post to 1 with the value David.
Congratulations.
And then we get congratulations. Your reward is at /public secret picture 1234. And this is where I have let you down, because if I go to /public /secret 1234 picture, I get a cannot get. So you can't even get your reward. And the reason for that is I want this server to statically serve stuff in the public file. So these rewards. And we haven't set that up, but we can do it with middleware again. And I can say server.use. I only want to use this middleware for a specific route. So when people do public, and then I want to say express.static and then /public. Or just public. This is a function of Express itself. I'm using it as middleware to allow anyone to make a request to public and just get static resources. Static resources are things like images, CSS files. It could be HTML files if I want. But this is just saying don't handle it by routes. Just give whatever they're asking to them. Or whatever they're asking for to them, as long as it's in this public folder. So now, if we head back here, we get reward number 1. I don't know. I'm going to leave the second and third questions to you guys. I'll leave the server running if you want to try and practice with posting. Hopefully, I'll leave it running for Calgary. You guys will be able to access it too. If you want to answer the riddles for mission 2 and mission 3, for all of these questions, it will be a single word, and we didn't add any case handling in our server. So if you just give them as like lowercase answers, that would be the easiest for you. Sweet, so let's just end with a quick review of the Express server that we used. So it's fairly simple to set up new routes. We can do pattern matching for a route. Ours was missions/ID. This is if we wanted to get a particular person back from the server. We also saw view templates with EGS at the end. There are different template systems you can use when you have an Express server. We used EGS, and with your project this week, you'll use EGS as well. It's essentially just HTML with special sharp bracket tags where you can pop in some JavaScript. You can define like a general case. The reason they're called templates is we have a general case, and then they get filled out specific to the data. We have a general, where are we going? We had a general mission template, but they look different depending on which mission you're viewing. You can get, way more advanced than this as well, so that they are more customizable depending on which resource you're viewing. I've also included a bunch of additional resources when I send you these notes, so you can look at Express, EGS templating, middleware, more on HTTP transactions. Express has fairly great documentation. You can dig through it and look at it. We can close. Anyone have questions on our Express server and how it ended up, I would use the codecast if you want to like dig through the code a little bit to look for something specific. Yeah, if there's any questions, we can jump into them for a bit. I know we're over time a little bit, but I think it's good if you guys have any questions to address them. Well, good. Cool. Thanks, guys. Yeah, I want to hear congratulations for the other two missions. So someone answer them.
Can you show us how to post again?
In Postman? Oh yeah, for sure. Sorry, maybe I should have been. Let's see. So if you have Postman open, it should just bring you to a page that looks like this. You have this drop-down kind of menu here. By default, it might be at Get. And the first step is to find the method you want. So we want post. For the URL, for myself, I could use localhost. But for you guys, you can do the ngrok link /answer, and then this is where you could dynamically say /1 /2 nice /3. You're gonna click for your request under these tabs. You want to hit body, and then here under key and value, you would hit answer for your key, and then value whatever the answer to the riddle is, lowercase in our case. And whatever you put in there once it's ready, I guess the other step is to make sure that the form URL encoded one is selected, because that's how we're processing our post data. You hit send, and you should either get a try again, or when we put David here, we got the secret image that we could use. Things to watch out for: if you hit the answer and then hit enter, again, we don't have a really sophisticated way to compare answers with the solution, so it's going to try and compare David with a new line. So make sure it's just the text that you got. If it's still not working for you, I'm around mentoring, so just like wave me over and I'll come look at it. Or Calgary, you can hit me up on Slack and I'll respond there. Nice. Some good pictures in there. You just don't know. Sweet guys, thanks. I'll let you head off to town hall. Thanks, Calgary. Again, if you have any questions on the lecture, just hit me up in Slack. Thanks, guys.